Okay, here we are in day 5, continuing where we left off. Number 17. It says, find the derivative of the function. Five x squared minus 2, 6x squared plus 3x minus 3. We're supposed to find f prime. All right, what we do here is first thing you want to usually do is see if you can factor anything, see if anything cancels, see if we have a removable discontinuity. But since we don't here, this doesn't simplify any further. So what we do, since we have a quotient, we use the quotient rule of derivatives. The way I always teach my students, we have the f and g, you have h of x equals f of x over g of x. So f here, take the derivative of it, and then take the derivative of the g. So the original function is 5x squared minus 2. G is 6x squared plus 3x minus 3. Now we take the derivatives. 10x, 12x plus 3. Everybody catch up. And we're looking for, instead of memorizing a formula, once you have the top, you have the bottom, f, g, f prime, g prime. I always teach my students, use the Fishy method. What this one says is g, so I start from here, g to f prime. Since it's division, we're getting it smaller, so we subtract f to g prime. All over the denominator squared. So and the product rule, instead of a minus, we have a plus. But this makes it much easier to memorize. Use a little fishy thing. Everybody knows that fishy thingy.
Yeah.
So for our function, we have f prime. Shall everybody catch up? Go ahead.
Yeah.
You ever cut up?
Yeah.
That was pretty quick. So we take g, which is 6x squared plus 3x minus 3, times f prime, which is 10x, minus 5x squared minus 2, times 12x plus 3. All that over our denominator squared. Let's go ahead and fix the top. So distribute. We got 60x cubed, 30x squared, minus 30x, minus 60x cubed. That's some minuses. 60x cubed plus 15x squared 24x minus 6. Rewrite everything that we have. Just get rid of the parentheses, so we'll distribute the negative sign. So negative 60x cubed, negative 15x squared, 24x plus 6. And simplify, the 60x cubes cancel. 30 minus 15 is 15x squared. Negative 30 plus 24 is negative 6x plus 6. The book's happy with that. Can we go any further?
You can, yeah.
Yeah, we
Back to
could,
the bottom.
we could factor out a 3 out of the top. And same thing with the bottom. We can factor out a 3. Oh. So one of the 3's cancel. So we would get 5x squared minus 2x plus 2. It's not, it doesn't really save you that much time. So that's why they left it as this, because instead of having a coefficient out there, so. But that's, I will take any of the answers. Number 18. Find the derivative of this function. Instead of t for time, I'm using x because my t's look like numbers. This is find ds dx. Typically, what does s represent? Not a distance. It's before the distance. It's position. Yeah, it's the position of the object. Because yeah, we'd find the distance by subtracting the two positions. So how do we take the derivative of this one?
Product rule and chain rule.
We could. Can we rewrite this as something else?
Yes, because.
Because it's a negative exponent, we bring it down. Because I think the quotient rule here would make it much easier for us. Because yes, if we did the other way, we have to use the product rule, the chain rule, and that's just many rules at one time. This one, we have F, G, F prime, G prime. Oops. That's 2 plus x squared. So the derivative of f is -1. Derivative of g is 2x. So it's 2 plus x squared times -1 minus 6 minus x times 2x over the denominator squared. As I said, see, the first step is calculus, this part here. The rest is algebra. So we have -2 minus x squared minus 12x plus 2x squared. Two x squared minus 1x squared is x squared minus 12x minus 2. X squared plus 2 squared. And there's your answer. You finished? Yeah.
Mhm.
Okay. Number 19. Y equals 5 e to the power -x plus e to the 3x. Find y prime. The derivative of e to the power u is
E to the power of u. It's the same thing.
eu du. So if that's y, then y prime. Because we have to take the derivative of the exponent. So y prime, leave the 5 alone. The derivative of -x is -1. E to the power -x. The derivative of 3x is 3. E to the power 3x. Yeah. For ease, that's why I love ease. It's just leave it alone and take the derivative of the exponent. Almost impossible to go wrong with that. Okay, number 20. Number 20 is asking for, here's the equation. Y equals x to the 4th over 4 plus 4/9 x cubed minus x squared plus 3x minus 4. Find y prime, y second prime, y third prime, y fourth prime, and y fifth prime. So the first derivative. Bring down the 4, subtract 1, you get 3. Bring down 3, subtract 1, you get 2. And simplify. So there's the first derivative. Finish them already?
No.
Pretty easy. Actually, it's just a lot of writing in this. So that's that one. Number 21. Find dy dx of this. It's really asking. So let's do the first one. So we have the f, g, f prime, g prime. 3x. Derivative of 3 is 0. Derivative of x is 1. So for this first part, we get x times 0 minus 3 times 1 over x squared plus the derivative of sine is cosine. So that's 0. So our derivative is 3 over x squared plus 2 cosine x.
You wouldn't keep the negative on top? Or that minus?
Oh, yeah. Good catch. Good catch. Number 22. Find the derivative of this one, x to the 9th cosine x. We do the same thing. When we do a product rule, we have f of x times g of x. So f prime, g prime. X to the ninth cosine x. The derivative of x to the ninth is 9x8 negative sine. It's a product rule, so we add 9x8 times cosine x plus x to the ninth times negative sine x. Pretty easy so far. Number 24. Use implicit differentiation. To find dy dx. Five y squared equals 2x minus 3, 2x plus 3. What is implicit differentiation? What is the importance there? I mean, what is the procedure?
You take a derivative of both sides.
Of both variables. And whenever you take a derivative of y, you have to put dy dx because y is a function of x. It's a dependent variable. So here, let's take the derivative of this side. 10y dy dx. That's the left side. Now, on the other side, we have the quotient. 2x minus 3, 2x plus 3. 2, 2. We have 2 times 2x plus 3 minus 2 times 2x minus 3 over 2x plus 3 squared. Let's simplify. 4x plus 6 negative 4x plus 6. Four x's cancel. Six plus 6 is 12. Last step, we have to get rid of 10y. So we divide both sides by 10y. The 10 and 12 can simplify. So we have 6 over 5y 2x plus 3. There's your derivative. What are implicit equations, implicit differential equations used for? Related rates. So If you have a function that changes with respect to a function, then you use these. Because we always have to look at the y changes with respect to x, and so does the x, so the whole thing changes. For example, if we threw a rock into a still lake, you see the circles getting bigger and bigger and bigger. Each circle gets bigger with respect to time. So the diameter of the circles gets larger and larger and larger. That's a implicit function. Number 25. Find dy dx. Well, the derivative of x is what? 1.
One.
Now we use the chain rule. The derivative of sine is
Cosine one
cosine y
times y prime.
times the derivative of y is dy dx. To get dy dx alone, we got to divide both sides by cosine y. So our derivative dy dx is 1 over cosine y.
And the limit change to.
That equals secant y. Yes. Yeah, so if you take another step, do so.
Is the computer or?
Will it
or
take
the-
both of them?
Yeah,
I want to say yes, it should, because they're both the same thing. I mean, but if it doesn't, there's another reason I don't like those systems. They're only as accurate as the people who
Yeah.
program the answers.
yeah, because calculus one, we had a teacher that depended on this or the math lab.
Really?
And all the grading that came from tests and stuff came from math lab. And so you would have questions where it's like this and you'll end up with a mess of tangent and all this stuff. And it's like, okay, well, now you gotta find the identities and stuff. And it's just like, okay. If you don't know, if you can't find them online and you don't know them, then you already got the answer wrong.
That's not fair to you guys.
Yeah, but I guess like the reason they graded it that way is because they expect you to know a trick like that, but it's just like, it's too many identities to remember.
My question has always been, is this not the same thing as that? If it's the same thing, then why do I have to write? I mean, if I write this, I'm fat, dumb, and happy, because I like to deal with cosines, but I do, because if I was gonna solve this, if you give me some angle, I would convert it to this anyway.
Yeah, it's easier to work with.
So, yeah, and I don't like when professors do that, or instructors do that. If x cubed plus y cubed equals 56. Find d squared y dx squared at the point -2, 4. Oops, sorry. All right, so what do we do first?
You take the derivative of both sides.
Right, so let's first find dy dx. So we have 3x squared, 3y squared dy dx equals 0. Move that over there. So we have 3y squared dy dx equals -3x squared. divide by 3y². So dy dx is equal to negative x² y². But we can go a little bit further there too. Since we know what the x and y values are, we can determine that dy dx is negative of negative 2² over 4². Negative 4/16 is negative 1/4. So the value of dy dx is negative 1/4. Okay, so for here, we pick up from this point. So we begin at dy dx equals negative x² y². Dy dx is negative 1/4. At that point. So the derivative of dy dx is d² y dx². We have a quotient rule. So we have negative x² y², negative 2x, 2y dy dx. Negative x², 2y dy dx over y² squared. So on top, we have negative 2xy², negative x to the positive, x², 2x² y dy dx, y to the 4th. So that is our formula for it. What do we do now?
You can cancel out. Can you cancel out?
Well, we can factor out one of the y values. We can factor out one of the y values. We get 2xy plus 2x² dy dx. So that cancels one of the y values. Negative 2xy, 2x² dy dx, y³. Because nothing else cancels. We can factor stuff out, but it's not going to do any good for us. Well, we could, as if we factor it out, we can factor out a negative 2x. That will give us a y plus x. dy dx. The only thing that's going to do is make it easier for us to plug in numbers. And we have these numbers we have to plug in. So d squared y dx squared is equal to -2. X is -2. Y is 4 plus -2. dy dx was -1/4. 4 cubed. Now we just do the algebra. Negative, negative is a +4. Positive, negatives, and minus, so it's 4 minus 2 is 2. -1/4. Well, that gave us the same value. Because here the 4 will cancel, gives us -2 over 4 to the third.
I think we put minus over. Yes, can you check the sign, so?
Yeah, it's
-2xy, there should be, I guess, plus 2x squared, yeah, down there, down there.
plus, okay. So when I took out the -2, so that should have been a minus, so it changed to a plus. So that should have been a 6. So we'll end up with -6 over 64. -3 over 32.
Okay,
That's if I didn't make mistakes.
can you go up a little bit?
Yeah.
Oh, no, not too far, I just need to see what it simplified to on there.
Okay, that's right. Let me just now let me just plug with this one here. Because that's where I know is for, again, whenever you, the more work you do, the more chance of error you have. So let me now plug in this equation. See if we get the same answer. So we have -2xy squared, 2x squared y dy dx. We have -2, 4 and -1/4. So we have -2 times -2 times 4 squared. -2 squared times 4 times -1/4. 4 to the 4th. +4. So it's 64. Negative and negative becomes a plus. The 4's cancel. Change the signs again. I now came up with a 9/32. Okay, let me go back and check this. So we got y squared times -2 minus -2 over y squared. So the -2xy squared plus 2x squared y divided by x over 4. So whatever this answer is going to be should be the correct one because that's straight from this part
Before the factoring.
before the factoring. Because yeah, the more stuff you do, the more chances of error. So let me try that one more time. So I have -2xy squared plus 2x squared y dy dx over y to the 4th. And the point is -2, 4, and the dy dx is -1/4. -1/4. Okay. Try this one more time. -2 times -2, 4 squared, -2 squared, negative is a positive. 4 times 4 squared. Negative is a negative. 2 squared is 4. The negative and negative cancel. One of the force cancels. Okay, so 4 to the 3rd is 64 plus 8. 196. That 196. Yeah. Sorry about that. 56. Yeah, so we simplify that. Half divide by 2. I get 36. 128. Half of 36 is 18. Half of 128 is 64. 9/32. Yes, I don't know how I got a -3/32. Which one was that one? That was number 26. Um, 27. Oh, 27 is a graphic one. I'm sorry. Here you go. Okay, this one. This one tells us when x is a, f prime is 0. At b, f prime is 0. At c, f prime is 6. F prime represents what?
It represents the slope.
The
of
slope.
f of x.
If the slope is 0, it means say If the slope is zero, it's a vertex. So we know we have to have vertices at A and B. A and B, A and B, A and B, A and B. Then at C, the slope is 6, which means it's a increasing or decreasing function. Increasing. So it could be that one. It could be that one. It can't be that one, and it can't be that one, because those are negatives. So which one do you think it is?
It has to be,
Why, which one can it not be? It cannot be A, because you have solid points.
yeah, which means that there's.
No kind, no defined, yes. So we cannot use A because this has points. Has to be a smooth curve. So the answer is B. Determine all critical points for the function f of x equals negative 6x squared minus 2x cubed. Okay, so number 28. Write it down. What does it mean by critical points?
Would be when the function goes from increasing, decreasing.
So what point is that?
You would take a derivative, right?
If we find the derivative, do we find this? We find the slope, but
You have to make it equal to 0.
set it equal to 0. So we can factor out a negative 6x. Set both of those equal to 0.
It stopped recording, or not stop recording.
No, I don't want to leave site. Oh, that's not my recording. It was since I was dormant in. Make sure. Yeah. Yeah. So now so what we're looking for, you're right. In order to, if it's increasing, if the graph is increasing, that means the slope is positive. The first derivative is greater than 0. If it's decreasing, that means the first derivative is less than 0. Between there has to be where the first derivative is equal to 0. These are your critical points or critical values. That's what these find is. So x equals 0 and x equals negative 2. Those are our critical points. Determine all the critical values or critical points of this function.
Derivative.
You gotta find the derivative. Set it equal to 0. Factor out of 3 first, if possible. Three goes into 28 9 times with one left over, so 3 goes into 18 6 times. Let's see if we can factor this. Since the second sign's a minus, that means the signs are opposite. And the bigger number gets the plus. So what two numbers multiply to give you to equal 96? When I subtract them, I get 4. No calculator, use a pencil and paper.
Well,
I
and
think 12
eight.
minus 8.
Yeah.
12.8.
Cheater. Yeah, but yeah, this is the hardest part of the whole process. So it's 12 and 8, right? Yeah. So since this one's a plus, the 12 goes here, the 8 goes there. Set them both equal to 0. So x equals negative 12. X equals 8. And those are our, just looking for critical points. The critical points. And we'll do about 4 more. Just getting, or 5 more. Let's do 5 more.
Okay, and then the critical points are negative 12 and 8.
8. Mhm. Number 30. The first derivative of a continuous function y equals f of x is given. Find y double prime and then sketch the general graph. So the second derivative is going to be what?
Find double prime and graph. What, the f of x?
Sketch the graph, yeah. This is, yeah. Finally, let's sketch the general shape of the graph of f. So what does f prime tell us and what does f double prime tell us?
F prime just tells us the slope. If it's positive, it's increasing. If it's negative, it's decreasing.
Mhm.
F double prime tells us concavity.
Very good. It also gives us the point of inflection. We need the point of inflection to tell us where the concavities are. Another thing it tells us where the vertices are. So we have y prime equals negative x squared minus x plus 12. And y double prime equals negative 2x minus 1.
And that's just you reorganizing the,
Yes, because I want the highest exponent there. So set this equal to 0. I can factor out a negative 1. I got x plus 4, x minus 3. So what are my vertices? Where are they at? The vertices are the locations, are given by the locations of the critical points. You would think. But remember, we factor out a negative.
You have to distribute.
Yeah, so it's gonna change their signs, won't it?
Would be negative x minus 4, is that correct, or? Oh.
Well, yeah, it's gonna be the whole thing, because if we had negative x minus 4. Says, that's why they threw this one in there, because it's changing the whole, if we just factored this one. If we factor this one. What times what is 12? 4 times 3. X and X, but one of them has to be positive. Which one's gonna be positive? Because I have to have a negative, just negative 4x, 3x. I need a negative 4, negative x. So if I solve these, I get negative 4 and positive 3. Those are my critical points. So this equation. So we know we have critical values at negative 4 and 3. So obviously we can get rid of which ones?
Negative 0.3. Can't really see it,
It's,
but it would be the ones where negative 4.
well, we also know what? If the first derivative is degree 2, what's gonna be the degree of the first original equation?
Uh,
It's gonna have to be a cube. Because you notice each derivative, we lose an exponent. So since it's a cubic functions have this shape. So we know it cannot be this one. What else do we not know? What else do we know it cannot be?
that has to be. It has to be increasing.
It's a decreasing,
increasing.
because the first derivative, the largest exponent is negative. So it cannot be an increasing function. So it's gotta be one of these two. Does this one have vertices? That's what this would tell us. With this one, where would be our point of inflection?
Our point of inflection would be. Um. Positive 2?
Set this equal to 0. Yeah, and so you have, move the 1 or move the 2x over. So x equals negative 1/2. At x equals negative 1/2 is our point of inflection. Does this one have a point of inflection? Yeah, it does, but where's the point of inflection for this one? At 0, 0. The point of inflection for this one is somewhere around there. So again, by looking at all those facts, we know that it's gonna be that one. limit as x approaches 6 of this function.
Uh, use the Hopfish rule.
Yeah, because if we plug in 6 in there, we'll get 0/0. It's not gonna work too well. So L'Hopital's rule says, let's take the derivative of the top and bottom. So the derivative of the top is 8. Derivative of the bottom is 2x. Plug in 6. So we have 8/12. 4 goes into 8 twice. 4 goes into there 3 times.
Wouldn't the derivative of two x squared be 4x?
Before, yeah. You're right. So it'd be 4 times 6. So that makes it 2. 2/6 makes it 1/3. Okay, 32. And we're not even on the last page of the.
Yeah, still wants 4 more or 6.
On number 32, it says use L'Hopital's rule for this one. If we plug in 0, we get 0/0.
I'm sorry, is it cosine x and then parentheses -1?
Yeah, I'm sorry, yeah. It's cosine x -1. I'm sorry, yeah, I should have put the parentheses in there. So this one is 8x. The derivative of cosine is negative sine.
Would still be 0 total.
So it's 0/0. So we have to take it again. Derivative of negative sine is negative cosine. So the derivative, the answer is cosine at 0 is 1. So it's -8/-1. The answer is -8. I know, it just so happened we kept on 0/0. 33. Another L'Hopital's. H goes to 0. E to the power h minus 1 plus h. E to the 0 is 1, minus 1 is 0, 3 to 0. So that one, it's 0/0. The derivative of e to the h is e to the h. The derivative of h is 1, so it doesn't matter. Minus the derivative of 1 plus h is 1. Derivative of 3h is 6h. No, plus the squared move down.
So we still get a 0.
We get 0, 1 minus, so 0 over 0, we gotta do it again. You have to do it again until it's no longer 0 over 0. So we get e to the h over 6, which makes it 1/6. Thirty-four, using, oh, there. Yeah, you got it?
Yeah.
34, using rectangles whose height is given by the value of the function at the midpoint of the rectangle's base, the midpoint rule, estimate the area under the graph of the following function using 2 and then 4 rectangles. Holy smokes. Using rectangles, okay. So we have y equals 64 minus x squared between x equals -8 and x equals 8. Using rectangles whose height is given by the value of the function at the midpoint of the rectangle's base. Okay. Estimate the area under the graph of the following function using 2 and then 4 rectangles. Oh, you know, what is this saying?
You see, finding the area under the curve, but using the midpoints.
Yes. What does this graph look like?
Say,
It's half a circle. It's a parabola opening down. Well, no, it's the, at x equals 0, it's 64. Okay, so to look at it that way. Now it's saying that using 2 rectangles. And the midpoint of the distance, midpoint of the rectangle's base, which is at 4. So what this is saying is we're taking the sum of 2 rectangles. So the height, y1 is 64 minus 4 squared. And y2 is, this is -4, but it won't matter since it's squared. 64 minus 4 squared. 64 minus 16. 64 minus 16 is 48. And 48. So now what we gotta do?
you gotta find the area.
So the area is the summation of f of x times delta x. So we have y1 times delta x1 plus y2 times delta x2. So what do we get? What is our delta x?
Delta X is, 4, isn't it? Or eight, is it 8 minus
Is
4?
8,
Oh,
because that's the
oh,
width
because it's
here.
two rectangles.
Yeah, so it's 48 times 8. 48 times 8. Is 768.
And that's for 2 rectangles.
That's for 2 rectangles. We do the same thing now for 4. So here we have to take at 2 and at 6. At -2 and at -6. So for the area here, we take the summation of I equals 1 to 4. F of xi delta xi. The delta x is going to be 4 units wide. So we have to find the f of x's at those. So f of x at 2. 64 minus 2 squared. 64 minus 4 is 60. F of 6 is 64 minus 6 squared. 64 minus 36 is 8. And it's going to be the same for these guys here also.
It's 64 minus 36 is 8.
Oh, no. Is 28. 28. It's new math. So we have 60 over here, 60 over here, 28 here, and 28 there. So we take 60 times 4 plus 60 times 4 plus 28 times 4 plus 28 times 4. So f of x1 delta x plus f of x2 delta x, f of x3 delta x, f of x4 delta x. So it's 28 times 4, 60 times 4, 60 times 4, 28 times 4. 112, 240, 240, 2, 4, 5, 6, 4, 8, 9, 10, 4, 704. So the area using the midpoints is 704. I need to find the rules for the Ks. So we'll jump to 37 right now. I just realized I didn't print those out for y'all. So the summation of a constant from 1 to 7 is the same thing as the constant since it's added 7 times, 28. Same thing here. Since it starts at 1, goes to 500, and it's the constant added to itself 500 times, you get 3,500. Now the last one, it starts at 2. So if we start at 1, go to 240, we get 30, and we add it 240 times. But we take away 1 that we didn't count. So we get 0, 0, 12, 720 minus 30, 7170. And we have 2 more that, but I have to pull there are certain rules for Ks when we have summations. I'm sorry, I didn't show you this. Oh, we have one more. 38. -7 to 9 x over 2 plus 9 dx. So we can split this up if we want to x over 2 dx, 9 dx. We can do that.
I was reading ahead. Can you do substitution method on this or no?
What would you substitute?
The inside function,
How?
wouldn't u equal x over 2 plus 9 and then? Oh, well, no, never mind.
Yeah, no, this one is just straightforward. You would, the first thing you would look at, if it's more complex, yeah, you would just look at,
So if there was a square, it'd be possible?
Yeah.
Okay.
yes. Actually, that'd be the first thing you would look at. So in this first one, this is the derivative. So where did it come from? So we can take out this first one, we can take out the 1/2. So we have x. So the integral of x is x squared over 2. The integral of 9 is 9x. Because the rule for integration is this. N plus 1 over n plus 1. And if it's indefinite, you have to put a c. But since we have a definite integral, so here we have 1/2. Start with the top. 9 squared over 2 minus negative 7 squared over 2. Plus 9 times 9 minus 9 times negative 7. (81 over 2 minus 49 over 2). 81 plus 63. So the denominator is going to be 4. So it's 81 over 4. So 81 minus 49 is 32 over 4, which is 8. So all this right here equals 8. And then 81 plus 63 is 2. Answer is 152. There are multiple ways you could do this as well. This is not the perfect way. It's just the way it's comfortable for me. You could have just taken both of these and had x squared over 4 plus, you had x squared over 4 plus 9x, and then taken it from there. So you could have done x squared over 4 plus 9x. So you have the first part, we have 9 squared over 4 plus 9 times 9 minus negative 7 squared over 4 plus 9 times negative 7. 81 over 4 plus 81. 49 over 4 minus 63. And we would have gotten the same answer. So 81 minus 49 is 32 over 4 plus 81 plus 63. 82 over 4 is 8. So yeah, you could, any method you feel comfortable with, you can do it, get the right answer. All right. We'll do the last two next time and we'll start the chapters. We'll start the chapter 5 review we'll start with 5.5 and 5.6, finish up chapter 5, and then jump to chapter 6. Did everybody get a copy of you get a copy from the back?
Oh, yeah, yeah.
Okay, because yeah, it's the schedule of stuff where I'm gonna try to keep. I don't mind starting off the semester slow in any of my classes. The slow, get everybody on the same page, and then we can pick up pace and catch up. So I'm hoping by spring break, we'll be caught up, so we can take it much slower and easier after that. All right,
When is spring break?
I think the second or third week of March.
Okay, so a month from now or more.
Oh, yeah, we have plenty of time before this.